Hi, I'm Remy Pengel with the Center for the Advancement of Sustainable Energy at JMU, and I'm making this video to help those of you starting the wind challenge to better understand what's in your kit and how to get started. So our wind competition is a challenge where we have asked you to build a wind turbine to generate the most power in a wind tunnel or in front of the fan. And this year, because of COVID, everybody needs their own kit. And we didn't know if everybody would have access to all the different resources, so your kit is much bigger than normal. The first thing we have is all of the PVC pieces you need to make a basic tower for your turbine. So you're welcome to make this tower any way you want. The big piece here is going to be the main tower part, and then the other pieces you can fit together in any way you want to make a stable base. I'm missing a piece, but otherwise this is kind of the standard base. Makes it relatively firm so that you can stick your turbine on top and stick it in front of the fan, and it'll do amazing things and generate electricity. To make your turbine, this would be the nacelle, the part that's generating the electricity. You're going to take the generator that we gave you and you're going to stick it inside the coupler. The coupler is attached to that little 2-inch piece of PVC, and then that's fit into one of your T-couplers. And this is just going to pop right on top of your turbine tower. Ta-da! Easy peasy, right? And then you can move from this to what we call the advanced nacelle, which everybody also got in their kit. Yours is a different color than mine, but the idea is that you have this. On one end goes the gearbox. You have your hex shaft or drivetrain that came in this bag here that goes through the top hole. And then we'll talk about the hub and how you attach your blades. In this scenario, your generator, which I don't have another one to show you, but your generator would sit in this little cradle here. And the littlest gear, I highly recommend to go on the shaft of the generator. So it would pop on like this, and it would sit in that little cradle as opposed to sitting in this coupler. And so when your blades are attached up here, they spin the big gear, and then the big gear would then turn the little gear, and then that little gear would then turn the generator, and you would be able to have even more output from your generator and generate more electricity. So the gearbox is definitely something that you're welcome to play with. Not required for the competition. This is completely fine. But if you're advanced and you want to work on that, there's a bunch of different gear sets. You can play around with different gear ratios. And if you get with a teammate who has another one of these, you can make multiple stages to your gears, so this can get super exciting. But for today, we're going to focus on just the direct drive, so we can get a better idea of how you might make some blades and attach them and generate some electricity. So we're going to focus next on this piece here. So this is what we call the hub, and the hub is where the blades are going to get attached. And then there's a screw on the front, which helps you to secure the dowels, the wooden sticks that you have. Those get attached to blade materials with your glue gun. You just glue them right on in any which way you want. They get stuck in, so you're gonna unwind it a tad to loosen it up, stick a stick in, tighten it, finger tighten it so that you can untighten it later. The other side of your hub has a hole. That hole is going to fit right on the shaft of the generator. And now, when the wind blows, the blades are going to spin the hub. The hub is going to be attached to the generator, and then the generator is going to generate electricity. And we can measure the output of the electricity using your multimeter. All right, so with the multimeter, the black one goes on the bottom, the red one goes right up above it. And when you turn it on, you want to turn it to direct voltage, which is going to be to the left. It's got a straight line and a dotted line next to the V. you want to be on the 20 scale. That means it's going to show you anywhere from 0 to 20 volts of electricity. You're never going to generate more than 20 volts, so that's a perfect scale for you. So all you have to do is connect red to red and black to black, which is made easy by your alligator clips. So we'll take black and black, red and red. And the key is you want to make sure nothing is touching each other. So if the red and the black, anything, touch each other, it shorts out your circuit. You want to keep those separated. And so when I turn the shaft of this generator by spinning the blades on the hub, you're going to see little numbers showing up, not very consistently because I don't have the fan on. And this is how you're going to record your output voltage. For the online submission, you're going to need to be able to read this number. You also need to understand the resistance of your load, which in your kit, I don't have in front of me, you have a small resistor. And it's like, it looks like a wire with like a little bit of ceramic blob in the middle of it. And you're going to need that in order to close your circuit and be able to accurately measure your voltage for the competition. And I can make a separate video on that. Okay, so now that you know how to attach the hub to the generator, let's talk a little bit about blades. So I think a lot of people are like, where do I start? And where I would start is with making the simplest blades that you can. So we gave you some of this corrugated plastic, right? All I did was cut 2 of these sheets in half. Now I have 4 sheets. I attached the dowels using my glue gun. So now I can start experimenting with what works and what doesn't. So the first thing I would do is I would take your 4 blades, and the key to good blades and to a good rotor is balance. So you want to make sure that you space them correctly. When you've got 4 blades, they want to be crisscross, okay? Then the next thing, while you're trying to figure out how to attach these, is the angle. So if you notice right now, I don't know if you can tell, but my blades are facing in all weird directions. You got to pick an angle. So I'm going to pick this blade, right? And then I'm going to make it so all of my blades are facing roughly the same angle. Now, if I want to get super accurate, you pull out the yellow protractor that I gave you, and you set it right on the hub, and now this is your angle. If it was my angle, it would be back here. And I would say, look, that's at 20 degrees. So now let's look at the next blade. That's at 25, so let's shoot that one. And this one's at 20, that's pretty good. This one's at, whoa, 30, let's spin that a little. Okay, so now those are all roughly the same angle. They're all facing the same direction, so the hand test, make sure. And then I'm gonna tighten it, just finger tight, pop it up here onto my generator, and then if I put the fan on, those are gonna spin, and I'm gonna read the output voltage from here. Okay, so my output voltage, let's say, is about 0.5 volts. That's not too bad, but let's think like a scientist. Let's change one variable. Keep everything else constant. I'm going to change the number of blades because that's easy to do. I'm going to take a blade off. What did I say about balance? Does that look balanced? No. Okay. The key with 3 is that there's little triangles on your hub that tell you how to distribute your blades, which is super. So now I've got my 3 blades, but now I got to do the hand test again. Okay. There's one. There's one. There's one. They look pretty good. I could use my protractor to be accurate, make sure they're all at 20 degrees again, because otherwise I'm changing a second variable. You don't want to do that. All right, so now we've got 3. And when we stick it on and we place the fan the same distance, on the same speed, everything else is the same, and we read the output voltage again, now maybe it's at 0.6 volts. So we increased our output. So that's a positive thing. So you should be keeping a notebook of all your experiments. And then the next thing you might say is, well, okay, that was great, but what's something else I can change real quickly? Well, I can change the angle. So if you loosen it up a little bit and use your protractor, and instead of 20 degrees, let's try 40 degrees. So we're gonna steepen all these. And we're gonna stick it back in front of the fan. All right, so this is what you're gonna do. You're gonna iterate different things that you can change to see if you can increase your output. There's lots of blade characteristics that you can change. As you can see, I've got these 4 basic rectangular coroplast blades. But what happens if you make 2 blades and you make them super big and they look like wings? What if you have 2 blades but they're skinny and they look a little bit different? Less surface area. Ooh, what happens if I make 3 of them and instead of them being flat, I shape them like an airfoil? Will that make it any better? And then if you want to get real creative, you can use the pie pan method and you can stick your hub right through the middle of that. So there's lots of things that you can do. And when you're doing this, remember, keep your notebook, take lots of notes, lots of data, change one variable at a time so that you know what you're attributing those changes in your voltage to. And keep all of your blades because the judges will want to see this when you make your presentation video. I hope this was helpful. Again, I'll make another video if necessary about how to play with your gearbox and also how to set up your multimeter to measure voltage over your 30 ohm resistor. Thanks so much. Good night.